now we'll, okay. Okay, now as an architect, let's say we can go and debate, and I also can go and debate with each one of you here. As an architect, we have to only focus on system design, or we should also understand the OS internals. Anyone here who would like to comment? We need to also understand some OS aspect also, or only system design is fair enough. What do you guys comment, guys? Come on, comment, or anyone can speak. OS also. Okay, cool. A great architect, from my perspective, a great architect would understand not only system perspective and also in the terms of the OS perspective. Because from my experience, I'm telling.
I ask one question more about that related to the earlier discussion.
Yeah, you can take a little bit. Maybe you can give 5 minutes time. I'll take your question, please. Okay. So I'll take your question. Give me 5 minutes time. We'll just start with. So what is the key architect will have metrics in the UPS system is that the total end-to-end response time that he will target between 1 to 2 seconds. Okay. And the bottleneck under 5 crore user per day, that it should happen very faster. No bottleneck should be there. Okay. And also the Kafka doesn't wait. It doesn't wait. It queues or UPI request or lets the router handler process independently, because it will process everything independently. So the Kafka write latency is very important. What is the write latency? Typically, it should be less than 10 microseconds, milliseconds, sorry. Kafka read to process also should be this process. Generally, write and read is slower, right? That is what a key architect will see, these two aspects. Then the key architect will also see how DB handles scaling, because we are doing sharding by transaction ID, user ID, preventing single node overload, connection pooling. This is very important because we will have to do thousands of connections for database. How do you handle that thousands of parallelly? Partition tabling, how to fasterly insert and delete and all. Then async writing with Kafka, mainly doing that. So then how do you do with async write with Kafka? That's also no waiting. So generally all your DB latency should be this measurement. So I'm not talking about the architect. I'm telling about a core product, because in my experience, I've done 7 to 8 architects, which is a great industry products. So the key was the latencies. When we set this latencies, that is going to be there. As I explained you here, in our case, what will a great architect do is here. If you see in the case of this Paytm scenario, if I want every transaction to happen async processing. Async processing means what? It is not It is not going to be in my case. It's all synchronous. It is asynchronous. Asynchronous means what? It will take a request, and that request will go and process asynchronous. The user may do a synchronous request, but it will be processed as what? Asynchronous. Because if you see here, for a normal user, he is a synchronous guy. Synchronous guy what? He is holding his phone in hand and he is waiting for the payment response. But in the background, our systems are working as asynchronous. So in the meanwhile, it is using Kafka with UPI router, handling REST asynchronous. It is getting a bank response and then doing all asynchronous. It's no authority for user, but it's all happening asynchronous. So your response time should be this much 100 micros milliseconds, and your processing time should be in this time. So you have to both scalable independently. Okay, and that is very, very important. So this is the overall latency. So I will talk about from my experience. A high level system design wasn't the biggest problem. If you see an example of Paytm, the failure was due to runtime behavior under concurrency. Remember this. So their problem was concurrency was a runtime behavior, and thread starvation, unbuffered APIs. And also there was a business layer logic which was not scalable implementation, or that was not basically kind of a lack in the system. So a system can look well designed, but it will always fail in production due to runtime concurrency or kernel level bottlenecks or whatever it is. In this case, in case of Paytm, I'm talking about the final, as an architect, when I say from my side, UPI routing logic, yes, definitely it is an improvement from system design side. but OS level side not, but application layer maybe side not. But API retry handling, that is a good for system design. OS level, yes, somewhat, but concurrency limits, performance tunings are the more key layers of OS level interventions. This is something as a core developer may not understand, but a core architect has to go behind the scope of his understanding, because he has to go behind the scope. When I say behind the scope, in some applications, especially Java based, C++, C sharp based, we have to go behind the GCs, what's happening, behind the memory leaks. You have to go deeper in deeper context. Okay. So more than this, how they fixed it, they added a routing logic. They built a new UPI router, Go based, and asynchronous infra. When I say asynchronous, I said that I use this word. They switch to Kafka for storing all the data. And they use concurrencies, generally Go routines, because it's better than thread handling. Monitoring, they added a lot of circuit breaker and time thing, and OS infra fixes. At kernel level, we do some kind of limitations, we enable them. We all did that behind it. And the mastery monster, when I say mastery monster, that most of the core developers will, even if you see the system failures of real world, like examples, Paytm, IRCTC, Zerodha, maybe you would have come across, even NPCI had a big, a kind of system halt. Okay, Axis Bank, we all have seen this. Maybe you heard about it. No, not at all. But a real core guy, tech guy would have heard about it, explored about it. They all had the same problem, that what went wrong. They had a lot of OS level implementation, queues and thread blocking calls, thread exhaustion, queue kind of thing, event looping mechanism they had blocked for long calls. Okay, this was a real monster that you would have never come across. There was a lot of business logic still in the real world. They still have a legacy problem in their retry, circuit breaking. Okay, a lot of implementations, circuit breaking implemented in Axis Bank, Paytm, Zerodha, a lot of organizations, right? They didn't isolate, there was isolation failures, there was duplication requests. So there was organizations where there was scalability issues, scalability of microservices, like SDFC Axis Bank had the stateless service design, which has been problem. And there were vertical scaling or horizontal scaling. There was such service issues. So there are many assets. So still you can see some of the banks, some of the international organizations, some of the rich companies in India, rich products in India still have their data layer design DB has problem because of heavy joins, their lack of indexing. Okay, there's no catching layer. Even now you see a lot of catching layer, but some of the bigger products have the catching layer. Every time hit DB, yeah, they use Radis. Radis also will have starvation, and I mean there's no separate read and write separation, and this has been improved in some of the systems now. Yeah, but yeah, majority of the systems are improving it. So the main thing is that still observability is the failover and self-healing is very important. Real-time alerting, which Facebook did, and Facebook and Snapdeal had this issue of they had a blue, green, and candidate deployment that they had issue, and that was their issues. So load testing is very, very important. Still, you see a lot of organizations are doing load testing. There are thing that can they handle 10x traffic? Because you see, even Flipkart, Amazon has big billion days. Actually, they do load testing that time because they see that can their user base be larger and they handle it. So it's all a failure injection, and it's a Facebook or Paytm or whatever it is. And so this is all how they handle 10x traffics. So if you ask me now right away this question, Venkatesh, can you tell me, if you say Paytm is, Paytm system architect, but now let's say, Venkatesh, if I know Paytm architecture, can I say I'm familiar with GPay now, Google Pay? Yes, absolutely. But GPay and Paytm has got business logic implementation layer is different. So, I mean, if you ask me here, your question will be in Google Pay, they have the PSP bank integration deep dive. They use native integrations. Okay. But PhonePe, Paytm, they use third party. Okay, so they use third party. They don't use the normal guy. They use a third party guy. Okay, but here this fellow will use deep native integration, because if you compare Paytm versus Google Pay, definitely Google Pay is winner because they have deep native integration of all the banks, but they use third party PSPs. Second thing, bank health prediction. Now, if you see, Paytm started using the our logic, right? We are using router and we are using handler and all. But Google Pay uses machine learning based scoring, and they use live health catching also. And retry strategy, they do multi-level retry. We do a basic retry. I mean, now we have also improved a multi-level, and a lot of aspects of it. Google Pay has better latencies and better, faster processing time, and they write directly PSP APIs and they interact with that. So when I compare now traditional routing logic, static routing was an issue. That's why they were hard coding. That's why they use basic retry 3 times. They fall back next time after that and doesn't adapt on the time or region based. If you use now, Google have adapted based on region. If it is Hyderabad region. If it is Bangalore, it's a Bangalore region. So region based also they did. Okay. So if suppose Bangalore is slow, then router will still keep sending traffic to it also, because that is the issue with here still. So as overall system, you understand there should be an intelligent routing business logic. Okay, that has to be improved in terms of with higher error ratio and with lower average response time in your city, and then dynamic fallback issues, and all this has to happen. So this is what actually is a monster. So what I would say as an architect or as a senior developer or as a junior developer from my end, always try to learn systems, but the system has a core business logic. If you see, always in the systems, the infrastructure tools, the patterns, the monitoring, and the API gateway, these all are common across all industries. But the core business logic for a business problem is what innovation happens. And this innovation is changing across the industries. Okay, and this is the key learning that you are doing it for today, and that should give you a happy smile today, because I hope most of you here would have some takeaways here, because you know some of the business logic implementations here. Okay, so I am here to give you a guidance on mentorship on terms of system design. If because I have transformed big companies, which is 150 crore worth projects that I've worked on. That is a high-end systems which we have built it. So with that experience, I can definitely give you a great mentoring in terms of understanding the core system problems, real problems I can discuss with you to show you focus on that. So there's no catches, just you can register and unlock with us in CoderRange. Okay. So I am here in LinkedIn. If you want to smile and if you want to continue your smile in tech, you have to continue a smile follow with me, because that is going to help you to smile in your career. And we are also available in our YouTube. Yeah, you can also continue your smile, continue there, be part of our CoderRange YouTube there, so that you will be always with us. And I'm open for questions and answers. Any questions, I'm always there